Today I'll be showing you guys how to scale different assets and offset them as needed. For example, to create much thicker sections, despite it being originally set up to automatically be positioned and scaled where it was, as well as the ability to just place doors wherever you'd like, really quickly and easily, and even have multiple if you so choose. And lastly, we're going to add a simple section here where we're able to really quickly add in an in-between where you can see all the walls here have been removed, but none of the other walls around it are removed. It is just the ones that are facing this way in between the two levels. So you could have a nice little walkway and create very interesting designs of your building if you so choose. So with that in mind, let's just jump into it. Let's begin with actually just changing up all of these scales. Right now, when we put a mesh in, we define the bounds that we want, and that's it. Can't modify it afterwards. So what if we do? What if I want to make this, for example, a bit bigger than it would be based on where it is? Or if we want to, for example, close up this little tiny gap that is here. For that, we need to introduce an offset as well as a scale mechanism that's kind of post all the changes. To do that is very simple. We just need to add a few extra functionality to our data asset. Let's begin by opening our struct and adding two extra parameters by hitting the add variable twice. And we want one that is going to be our scale, and the other one is going to be our offset. Now, both of these can go ahead and be set as vectors. And for the default for scale, let's set it to be 1, 1, 1. So that way, by default, it is the correct size. And if we want to modify it, we can. And the offset will be 0. After that, open your PDA file, your primary data asset file, and compile it. So that way, it realizes all the changes to the structs. And then you can open up your actual data asset. And here, if we open up one of the regular walls, for example, you can see now it has scale and offset. And that is the same for all of these. We just went ahead and added this functionality, which is excellent. So now we need to actually implement this functionality into the rest of the graph. So go ahead and open up your PCG building graph or whatever graph you're currently using for this. And we're going to implement it pretty much at the very end. And because we have changed the data asset, it is actually giving us errors. To fix that, go into the graph settings up above and the data asset, reselect it. But to make this sure that this doesn't happen again, change the data asset by clicking the data asset name on the left, then click on PDA modular to open it up and change it to a soft object reference. By changing it to a soft object reference, when you change something in this setup, it will not get cleared. Big shout out to you guys in the comments that let me know this. It has been very helpful. Thank you. Right after it's done all the calculations, it's gone the right size, it's about to place it, and then we want to offset it or scale it accordingly. To do that is relatively simple, but first, real quick, right now in our current setup, we have this PCG scale wall size, and we're doing an attribute partition based on the mesh, as you can see, and we're doing it again here, and there's really no need. In fact, I'm just going to remove this node, and I'm just going to pipe it all the way through without it. There's absolutely no reason to do it twice because it is already been done. And if we were to do it, we need to do it a different way anyways. So let's go ahead and create a little loop to go through all the points by mesh and then add the scales and offset accordingly. So here in our PCG loops folder, I'm going to right click and search for PCG and create a new PCG graph. This is going to be PCG offset transform. I'll go ahead and open it up. And for this, it's going to be relatively simple. We'll go ahead and open up the in and out. For the in, we will change the label to be just points. The usage needs to be set to loop because we want to loop on every single one of these points. And the allowed types will be point. And the only last thing we change here is the pin status. Instead of advanced, we're going to say it's required. And now for the output, we're going to say out points and change the allowed types to be point. And also change the pin status from advanced to normal. We have everything we need here. And now what we're going to do is just take our inputs and we're going to need to get those variables that we typed in. So in here we have scale and offset, and that's what we need to get. So dragging out of the points at the start, we're going to get attribute from point index. This allows us to specify which attribute we want. In this case, in an input source, we'll go ahead and specify offset, and I'll duplicate it, plug it into our points at the start again, and this one is going to be our scale. I'm calling it scale, but keep in mind that this scale, and if I do $ scale, is different. The $ scale is the one that's here, and the scale is the attribute that we have added. When you're adding the $ there, it is using kind of the default values that come with the point, like the point scale, the point's densities, etc. Otherwise, it's an attribute that is set separately. But now that we have this, all we need to do is grab ourselves a transform points here, plug it in right in between, open it up, and plug our offsets into offset min, offset max, and our scale into scale min and scale max, and close it up. Now, one thing to not forget is in the transform points, make sure to uncheck uniform scale. Otherwise, if you try to scale in just Z, it just won't do anything because it's expecting something in X to scale it uniform. That's all we need here. So now let's go back to our graph. So here in our graph, and grab our PCG graph that we made, drag it in, and create a loop node. And now again, this is going to be looping on the meshes. So we already are looping on the meshes during all of this. So what I'm going to do is just plug it in right before the static mesh spawner. Just plug it in right here. And I'm going to duplicate it and place it in here. This is for the walls right now. Plug it all the way through. And now if I zoom out and we take a look at our building, here's my regular walls and here's the scale. If I want to really thicken it up, I can, for example, say 2x. And you can see all the walls have scaled. I'm getting this, which is because of the duplicate on the inside. If I turn off open back here, you can see it is now just scaling just those pieces. So again, I can go ahead and scale it in height. Now, of course, in this case, this is kind of breaking everything. But if you want to, you can now make things thicker and thinner accordingly. That also means that if you want to, you can offset them like so. And it's offset in the local direction. It is not offset globally. So all of these are offset relative to where they're facing. What you can do is grab the bounds of it and actually move it based on the bounds. It'll be like a 0 to 1. One movement will be equal to the full size of whatever it is. Because right now this is kind of a overall movement and you can do it based on the size of the mesh. So it'll dynamically offset. If that's something you're interested in seeing, let me know in the comments below. But now that we have this, we just need to put this pretty much everywhere else. So I'm going to go around and duplicate it and place it right before the static mesh spawner here on all of our little different pieces. There we go. I've added it right in between all of the previous things and the static mesh spawners. So now if I want to, I can go back into my data asset, put up the corner pillars here, and now I can go ahead and just scale them. For example, I just scale them by 2x in the width in both directions. And you can see now we have a nice large one. We have a little bit of a gap here, so let's maybe scale it just a little bit higher in Y, so it just closes that gap. Now we still have this being just a little bit wider, but that's just the model and how it's designed. So if this kind of thing bothers you, for example, you'd want to make sure your model is on the same thickness at the start and at the end. So for example, we made that kind of change here and hard-coded it. And now we can go ahead and stop that from being hard-coded. And here in our roof border wall, we ended up doing a little bit of a scale here by 1.1. I can go ahead and remove this transform points and just plug it all the way through. So you're left with just this. And you can see it is a little bit off. And now in the roof border wall, we can go ahead and scale this. So we could scale in X by 1.1, for example, and that closes that back up. Now, in my case, this also scales the corner piece. So if I do like a 3 here, it is also scaling that corner piece. So if you want to have a separate scale for the inside versus the corner piece, so that way it all lines up still, just make sure you have a separate input for the roof border versus the actual corner piece. And then you will not have this little kink in there. But with 1.05 for the scale in X, it's really hard to tell unless you're really looking for it that it's actually kind of a little bit too big. So there we go. That is the scale setup done. Next thing we want to take care of is the thing that you guys have been kind of requesting ever since even the first series. And that is, how do you place doors and things of that nature specifically where you want them and not just randomized? So if you want, like, for example, 2 doors next to each other or a door in a specific location, you can go ahead and just place it. So let me show you how to do it just that. To get started, let's open up the PDA file where all our variables are. Let's duplicate one of them and call it doors. That way it maintains being a struct, an array, and exposed. Pilot and open the actual data asset here. And here we have a new input for doors, and go add an array. And now we can plug in a mesh. I grabbed a random one from Megascans here. I'll go ahead and plug it in, and I'll leave everything as it is right now. Effectively, how this works is we intercept the points earlier on. So we say, hey, if it's overlapping something, which is going to be our thing, then go ahead and spawn a door there. And if not, then spawn what you were going to spawn. So that way we're overwriting basically whatever was there with what we want. And this will work, of course, with our data asset to allow us to have variations if we wanted to. So first we're going to grab something that will actually work as a kind of a door selection. For that, I'm going to hit these quickly add to the project, and I'm going to search for box. I'm going to add a trigger box. This is just a convenient little box here with an icon. The main thing we want here is the box extent, because if I go ahead and scale this, it goes ahead and scales the box extent here. And what we're going to do is go ahead and give it a tag. So in the detail panel, I'll search for tag, and under the actor, not the tags component, you want the actor ones, add a new tag and call it door. And now if I take this and just position it kind of roughly where I want it for a door, let's say we want a door here, we will see what happens once we set it up. But here in our wall section, this is what we want to intercept. And we want to do it before the scale wall size, because obviously the meshes that we're going to be using are not detail walls or regular walls. They're going to be our doors. So what we're going to do is grab ourselves the get actor data node. And for this, in the detail panel, we'll change self to all world actors by tag, and we're going to specify door. Under data retrieval settings for mode, instead of parse actor components, we're going to get a single point. And this is very important. Make sure to uncheck track actors only within bound. This is basically equivalent to when you're doing on interior with a spline, you need to basically turn it off in this case to allow it to also work if you, for example, have it somewhere high in the air and not just in the bounds of the spline that you created. If you're working with only like a single floor setup, you could theoretically leave it on. And the downside, unfortunately, is the fact that it is now checking everything around. So some pros and cons with this method, but this gets us what we want. The first thing I want to do is check where the intersection between these points are. So I'm going to right click and search for intersection. The primary source is going to be our original points. So I'll go ahead and plug them in here and grab our get actor data and plug it into source 1. If I go ahead and debug this, you can see nothing has happened. But if I move this upwards, now you're starting to see that the points are here. That's because we're currently modifying the unique line here. We're not doing the regular walls. So as you can see, if I move it around, it is going to select multiple things. So great. We now have it selecting what we want. So now we need to not put these into the original graph. Now for that is just a simple difference node. And we take this out from the intersection, plug it into the differences, and the original graph here is going to go into the source, and the output of this is going to go into our wall. So now, as you can see, we're effectively just cutting the wall out wherever this is. So that's a good start. But now we need to go ahead and spawn the doors. And for that, we're basically going to be reusing this same setup for the doors. So I'll go ahead and take all of this, grab all of these nodes, I'm going to duplicate them over here so that we have our scaling, but we want to change from detail walls here in the property name to doors. So that way we're getting the doors information and scaling accordingly, setting up the close, open, back walls if we want to, doing the offset transforms, and then the mesh spawner. And for the actual connection here, we just take it from the intersection and plug it right into the points here. And now if we take a look, you can see there's the door. And if I move it around, wherever I go, it's going to have the doors, and I can make it really wide and grab multiple doors here. At the current moment, if I go ahead and just position this kind of awkwardly, you can see this kind of thing happens where it's not really getting the right thing. To fix that, all we need to do is change this difference node from minimum to binary. And now you can see it is now working as we'd want, where if it's overlapping, it is going to go ahead and do it. So that is something to keep in mind as I'm moving this around. The original points is set up to be here in the corner. So that's the kind of the corner you need to grab. And if it's too far away, it will not grab it. But now we have this. We kind of want to also do it for the regular walls, but we kind of probably want to start cleaning this up a little bit. To do that, I'm going to add a few named reroute nodes. From this mesh 1, I'm going to drag out and add a named reroute declaration node. I'm going to press F2 to rename it. I'm going to rename this to detailed walls. I'm going to do the same thing with mesh 2. I'm going to drag it out of here, add a named reroute declaration node, and I'll rename it to regular walls. So that way I can just plug them in directly here. By right-clicking, searching for detailed walls, I can plug that into the primary source and detach the original. And same thing here. I can duplicate it over, plug it into the source, detach the original. So that way it's nice and clean. And now I can take this entire section and kind of move it out of the way. And we still have this one cable here. So from here, I'll also add another named reroute declaration node. Press F2 to rename it. And this is going to be our detailed walls minus doors. And that's where we're going to plug into this scale wall size. Detail walls minus doors. And now I can go ahead and just select all this and comment it. I'll name it for doors for detailed walls. So now it's a lot cleaner and it is no longer messing up this entire thing. But now we need to do the same thing for the regular walls. So what I'm going to do is take this at the very beginning here. I'm going to duplicate it up higher. Instead of detailed walls, we want to get regular walls. You can plug that in. And same thing here in the difference node. We want regular walls instead of detailed walls. And for this one, you can see it has been renamed to detail walls minus doors 1. We want to do regular walls minus doors for the name here. And now what we can do is just reuse what we had before, because we need to have the exact same scales, the same open back settings, the same transforms. All of this needs to be the same. So what we can do is take this intersection and just plug it right in here. And this is our doors for regular walls. And at this point, all that's left to do is change up this here. So again, we can just delete this reroute node and search for regular walls minus doors and plug that all the way through. And now if we take a look, if I just move this down, you can see it goes ahead and rebuilds it as needed. And we can do all of them in one go. Multiple doors. The only thing I'm going to change at this point is remove this get actor data. So we only have one of them plugged into both to make it a little bit cleaner. So we only need to modify one setting here. And we want to probably turn on select multiple. Because we probably want to put in doors all over the place. And now if I hold Alt and I copy this around, you can see we're getting doors wherever we have intersections, just like that. And if I wanted to, I could put doors up above as well. Pretty much anywhere I need, we can have a door by just having it in position on any side at all. So just like that, really quickly, by placing 4 of these around, you can have the doors specifically where you want, and they will go ahead and line up with everything else you have. And if they didn't, you can go ahead and add an offset or add a thickness modifier, etc. If you guys are enjoying the tutorial so far, would love to hit the like button and subscribe for more awesome tutorials like this. Last thing I want to cover is how do you make connection between buildings? Because right now we have one building and just whatever is within it. But if we want to make a connection between 2 buildings and have it maybe be off the ground, we also want to remove the walls that are connecting them. So to do that, we need to modify a few things to achieve this. Starting with the fact that we need to basically modify the bounds and the extents of the points so they're no longer in the corners. Because if they're still in the corners, we can have 2 points in a corner where one is going up, one is going sideways, and they're actually on the same little spot. So if you were to try to cut it out, then it will cut out kind of not where you want. One way of getting around that is to have it be only facing the same way. So what we're going to do is modify our extents and the bounds, so that way we don't get anything extra we don't want. And then also we need to have a way of only getting the points that are facing in the same way or the opposite way if they're inverted. So that way we get them from both directions. And this is a bit more advanced, but I'll try to guide you through it as best as I can. Now, just like the other stuff, I'm going to be doing this right at the end, right before the static mesh spawner. This is primarily so that way we can just keep all of these onto the same loop system as they're all mesh based. And the following is going to be more of a point based system because obviously it doesn't matter what mesh is going to be overlapping. We want to be able to remove it from there. I'll start with the regular walls because it's going to be easier to demonstrate. What we're going to want is to first merge the points. I mean, wondering, like, well, we're only plugging in one thing. Why are we merging? If I select the offset transform, so press A, and here in the bottom left, select our PCG building, you can see here's our point data, and we have all of this separated point data. And if I select our merge points and press A, you can see we only get one. All of those separated things just got merged into the same point, which is what we now want. Because from here, we can do an attribute partition, and instead of filtering it by mesh, we want to filter it by index. So the way this is going to work is we're going to need to have another bounding box, sort of like what we had for the doors. But instead, we're going to have multiple cutout areas where we want to basically remove any walls from any of these meshes. So in our loops folder, I'm going to right click, search PCG, and create ourselves a new PCG graph. This is going to be our PCG remove not aligned. And I'm also going to create one other one. I'm just going to duplicate it to make it easier myself because it's already an empty one. And I'm going to rename the second one to check same rotation. I'll go ahead and open both of them up. And we're going to start with the remove not aligned one. For this one, we're going to open it up. And in the input, we're going to change it to points, label points, pin status set to required. And in the output, pin status set to normal, and allow types to be point. Now in here, we need to grab ourselves all the information from the things that we need to cut out with. Add another trigger box. And for this one, for the tags, I'm going to say remove walls. That will be our tag. I'll go ahead and scale it up and just position it somewhere around here for testing. So now in our remove not aligned node, I can right click, get actor data. This is going to be the filter all world actors by tag. A tag is going to be our remove walls. We want to make sure we are able to select multiple and turn off track actors only within bounds and make sure it is of single point. Last thing I forgot to do is in the input, make sure the usage instead of normal, it is a loop because we want to loop on all the points. Ideally, what I would love to have been able to do is take all of our points and then take all of our pieces and just check all of them for each one all in one setup. But basically what we need to do is put a loop in a loop because we want to take every single point. And when we have that point, now check for every single copy of our remover, of our wall remover, because we need to check the rotation of it relative to itself. So this check same rotation graph that we created, I'm going to drag it out here and create a loop node. And right now it has really nothing in here, but now we can go ahead and start setting this up. Under the check same rotation, we need to configure this as well. So our input is going to be our points. The allow type is point, pin status required, and we'll add another input. And this is going to be our overlaps. Allow types point. Usage is going to be a loop because this is basically going to be our little areas that we're going to be overlapping on top of them to cut things out. And pin status required. For the output, I'll go ahead and change the pin status to normal and the allow type to point. So now that remove not aligned, we can go ahead and actually plug things in. Get actor data, we can go into overlaps, and the input can go into point. points and the out to the out. And that's all we have in this graph here. The main part is here in our check same rotation, where we need to check that, well, things are lined up the same way. Now, to be able to check what the actual information that we have is, we're going to plug something in. So here in our PCG building, I'm going to take our PCG remove not aligned, drag it in, and create a loop node. And then I plug in our attribute partition into our loop. This way, if I go ahead and sample any point information, I can go ahead and read it down below. So we'll start by getting the rotation. And we only care about the rotation along the z-axis. So we can go and right-click, get attribute from point index, plug that into the points. And we also want to grab it from the overlaps because we need to compare the two. And now for the input source, what we want to actually use is $size rotation, but keep in mind that if I did just $sign rotation and I pressed A to sample it, and then we open up our blueprint building and we just take the first point here, you can see instead of the rotation being pitch, roll, yaw, we have quaternion. Now, I'm not sure why this is the case, why it converts it to quaternion, even though I've specified rotation, because in the original graph, if I go ahead and press A here, you can see it has a rotation roll, pitch, and yaw here with the values that we had piped in. So it's odd that it converts it to quaternion, in my opinion, but that's okay. Instead of rotation.z, for example, which still gives us a quaternion value, we need to do rotation.yaw. And when you do .yaw, it actually gets us the rotation. So if I plug in .yaw into both of them, and I sample the top point from our points, you can see we get a value of -90. Excellent. So that is the actual rotation of that point. So now we want to make sure they're aligned. So what I'm going to do is subtract one from the other by using a simple subtract node. And then I'm going to use a modulo node, which basically is like a divide, but it only gives us the remainder. So if we want to, for example, only check that something is facing within a certain angle, but we don't care how many rotations it has, we can use a modulo to effectively remove, let's say, 360 degrees from it, however many times, and only are left with the remainder. If one is, let's say, at 5 degrees, and one is at 365 degrees, and we have a modulo of 360, it will effectively result in both of those values being 5, in which case they're exactly the same. So in our modulo, in B, I'm going to drag out a search for create attribute, and in our double value, we'll go ahead and specify 180, because I don't care if it's facing the same way in one direction or the other direction. Then I'm going to search for less and grab ourselves a compare less node and get ourselves another create attribute, plug it into the in B, and this is going to be, let's just say something like 45 degrees. As long as there's a less than 45 degree difference between the two rotations, then we go ahead and say, yes, that's good. Now, of course, you can modify these values to suit your needs, but these are the values I'm going to go with in my case. Over here, we basically have a bool, whether or not it is true or false. So you can right click and search for a branch node and plug this output into output B. And based on this true or false, it'll output either to A or B. Now, the endpoint for our branch still needs to be our original points. So we'll plug that all the way through. And before we actually plug it all the way through here into the out, we want to make sure that these points are actually intersecting with our piece. Because if they're not actually inside of them, we don't want them to do anything. Because right now, we're pushing in through all of the points, not just the ones in the overlap. So from output B, I'm going to drag out and search for an intersection node. And the source one is going to be our overlap. And the output of this is what we're actually going to be pushing through, because anything else is going to go to nothing. If it does not match this, we go ahead and ignore it. We don't care about it. And before I leave here, there's one thing I actually missed here, and that is I want to make sure that this is always a positive value. I don't want negatives. So after this modulo, I'm going to grab ourselves an absolute node and plug that into the compare less. So now if I go ahead and sample this remove not aligned node, you can see we have some points selected because I have now a nice big area. And if I make it even larger and have it actually even deeper, you could see it is not grabbing any of the points on the side here. Now, as you can see, as I'm dragging this out, it's only grabbing these points. And if I zoom out, if I look at the other side and I keep extending it, you can see it's only grabbing those points. And if I rotate this by 90 degrees, I'll all of a sudden start grabbing the sidewalls. And if I make it bigger, you can see it is now grabbing just the sides here. Now, if you want to, you could make this, instead of 180, as I mentioned, make it 360. And now it's only grabbing this left side. It's not even grabbing this right side. So now what I want to do is use a difference node. From this offset transforms, I'm going to drag out and search for difference. And what we want to cut out is this remove not align. And that is when we want to plug into our static mesh spawner here. And now you can see you can use it to cut out the areas, but it's not quite great about it. As you can see, it is now being cut out. And we've left it as 360, so it's only cutting out the one side. If we change it back to 180 for both directions, we are now cutting out both sides, but we're not touching any of the other pieces that are on the other axes. Now what we can do is take this, scooch it to the side, make another copy on the left. Say have this one be a little bit taller than the one on the right. And now I can drag in a new building in here, make sure it has the same kind of wall size so it lines up and fits perfectly. So I've now roughly lined up between the two buildings, this kind of hovering section, and we can take this and place it in between. Now you can see we have now this open area here, which is great. It's connecting quite nicely, and I can move the buildings a little bit closer together so I remove this gap. One thing actually is happening is this right here, and the reason for this is this wall here, this one that's the problem, is part of this middle section. Well, this one isn't. So the points are not quite lining up between the two. So we can do select it and line it up a little bit better by moving it a little bit further to the right. You can see it goes ahead and disappears. And now I can modify this little box to remove this area from being affected. But you can see as I'm moving it kind of left and right, I get rid of this, but it also grabs this. So this is not quite a nice setup. Let me show you how to modify the bounds and the extents of the points to kind of get us what we want, which is just to be able to remove these points and not have it grab any other extra stuff around it. To do that, the first thing we're going to do is change the bounds of our mesh and the extents of our mesh. Now the bounds are basically the bounding box of our points. Right now, they're small little squares in the corners, as you've seen, but we're going to make it the size and shape effectively, assuming you put a box just around it, of the mesh that's underneath it. Now to do that, we're going to do that inside the scale wall size. I'm going to open it up and grab our PCG mesh to size. Because in here, we're already getting the bounds information, so we might as well just reuse it here, as this is the graph that we're using to automatically scale our mesh to the right size. So at the very end, right before the output, I'm going to grab ourselves a bounds modifier. I'm going to change the mode from scale to set. I'm going to open it up, and all we need to do is grab the bounds min, plug it into bounds min, and bounds max, plug it into bounds max, and close this up. If I just plug this all the way through now, when we do this, however, you might see that, well, for some reason, it seems that our cutout here in our middle building is gone. It's not working anymore. For some reason, when you change the bounds, it doesn't affect the extents of it, which is what the difference node needs to actually cut things out. The settings I found that works best to actually get this to work are the following. After the bounds modifier, we go ahead and grab ourselves an extents modifier, plug that all the way through, open it up to grab our extents. And the extents I understand as the size of the piece. So what we do is take our bounds min and bounds max, and we subtract one from the other using a simple subtract node. Then I want the absolute value because I want it only to be positive. And what I found for me is I want to divide this by 2. So I'll use a create attribute and divide it by 2 and plug this into the extents. For my testing, when I wasn't actually cutting it in half, it was way too big. And immediately as I do this, you can see it has gone ahead and removed these pieces. So here I'm in the lower floor, the middle floor we have not touched yet, and then the upper floor. And if I look around, you could see it has not removed anything else on any side, on any corner. Now, of course, the windows here on the middle level, we need to adjust because this is the detail floor, but otherwise we now have a nice in between here. So we're going to do the same thing for the points right over here. I'm going to take this and duplicate it right up here, take our offset transforms, plug it into the merge points and into our source, and plug the output here into our static mesh spawner. And now if I look here and I go down, you can see it is actually removing all of the floors. So we now have a nice in between. There's a hole here, so we can go ahead and move this accordingly to fill in the holes. There we go. I filled in the holes here. And you can see on every floor, we have this nice setup where we now have this section that is basically connected in between the two. And as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord will be down in the description below, as always. Thank you again to the patrons. Let's get back to it. And now with a few just additional lights in here, you can see it is now, you can see right through it, and it's now feeling a lot more alive. And one thing that's been bothering me personally is just because it's a tutorial, I've been using multiple here, so I'm going to just make it all so it's one design. And for that, all I need to do is go into our detail walls here and just remove one of these. I'll go ahead and remove the one with the balcony. And you can see just like that, we now have this one going all the way through, and you can see this one's taller, but it all lines up very nicely. For the cutout, just keep in mind that you really need to line up your modular pieces to be pretty much where they should be in relative 3D space. But once you do, as you can see, it works quite well. And if you enjoyed this tutorial, check out this video right here where I show you how to do some runtime stuff and maybe modify some stuff on demand.